for attending this session on connected automation. My name is Roger Berg. I'm with VID00077. I'll tell you a little bit about us a little bit later on, but the subject of my talk today is exactly what Mike talked about just before. It's called connected automation. So, like I said, let me tell you a little bit about what VID00077 does, usually at a wireless conference or connectivity conference. A lot of people might say, well, you know, I've never even heard of VID00077. So what VID00077 is what we call in the industry, in the automotive industry, a tier 1 supplier. One of the world's largest. We have 120,000 people on a global basis. Our main areas of research and product focus deal with powertrain, climate control, body electronics, and most importantly to this conference, driving control and safety. So if you look at all those kinds of areas in and around a vehicle, I think VID00077 can offer a kind of a holistic view. We do more than just instrument clusters, or more than just brake pads, or more than just safety sensors. We kind of take a holistic view of the vehicle and its surroundings, and that plays an important role here for what we call connected automation. So first I'm going to start off with kind of not really a vision for today, that doesn't really make sense, but a vision of what's happening now, some of the historical basis of what VID00077's done in the area of connected automation. So if this video will work here, it's kind of an introduction to what connected vehicle technology can do.
What if this didn't have to happen? What if there was a technology that could have prevented this? There is. It's called Connected Vehicle or V2X technology. It senses when an intersection is unsafe and warns you in advance so you don't end up in a situation like this. Last year, more than 30,000 people lost their lives on U.S. roadways. This technology could help drop that number to less than 10,000. It allows your vehicle to wirelessly talk with other vehicles, and with traffic signals giving you the information you need to stay safe. It can also help you catch more green lights than red, resulting in less wasted gas and a greener ride. Connected vehicle technology gives you a 360-degree situational awareness of your surroundings, all while keeping your hands on the wheel and eyes on the road. Today, it can prevent you from rear-ending the car in front of you, saving you an insurance claim. Tomorrow, it could save your life. Brought to you by VID00077, leading automotive supplier in connected vehicle technology, V2X. Be connected. Be safe.
So that gives you kind of a view of the whole concept of what connected vehicle technology can do and how it can enhance the safety of vehicle operation on the roadways. So here's a little bit more detail about what connected vehicle technology can do. I'm sure most of you in this crowd understand this, or if you're listening to what Mike had to say, it's fairly obvious, but I want to give just a little bit more detail about what it is. So what the device in the vehicle does is takes GPS positioning, time and positioning information, and the vehicle information itself, like such as brake status, how heavy is the driver braking, how fast is the driver going, are they turning right, turning left, various acceleration and such. And uses this data to actually record where the vehicle has been, where it is now, and kind of predicts where it will be. And this data is used by the vehicle itself and other surrounding vehicles to predict hazardous situations or potential collisions in the future, and warns drivers to try and avoid those situations early enough to elicit a kind of an evasive maneuver, either braking or steering in some other way, become more aware of the hazard situation. So having this technology built inside the vehicle and using the roadside systems and the GPS positioning and timing positioning availability, we've looked at integrating several different application scenarios, some of which are depicted here. And I'll talk a little bit more in a little bit more detail of some of these scenarios and situations and how connected vehicles and connected automation can actually to help prevent crashes and damage to the drivers and passengers. So in the first case, I want to illustrate what we call an emergency vehicle alert. So I'm sure all of you have experienced being in a car in a city or even on a major arterial, and you're driving along and all of a sudden you hear a siren, or if it's at night you see blinking red lights, and you're wondering, well, do I have to pull over? Where is this emergency vehicle coming from? How can I be safe? How can I be safe around this emergency situation? If I can find what do you call it? So the idea behind this application is that shared vehicle information about where a car is, where it's going, how fast it's going, where it's coming from, its relative location to you. We can advise the driver that an emergency vehicle is approaching, which direction it's approaching from, how fast it's going, and elicit some kind of, maybe not collision avoidance, but some kind of enhanced awareness, not just in front of you, not just behind you, but on crossroads as well. Here's a second example of using connected vehicle technology, in this case to actually avoid a collision at an intersection. So if you're sitting at a red light, and as soon as the light turns green, you're anxious to get where you're going, so you immediately take your foot off the brake and accelerate. In this case, if both of these vehicles have this inter-vehicle communication capability, you can be advised that the idiot who's crossing on the road next to you, who's going through his red light, is about to hit you, and it can warn you to stop. As the driver warns to take that evasive action that I mentioned before. And only because of having vehicle-to-vehicle communications can you be advised of this on a blind intersection scenario. A third application I can show here is what we call a stopped car alert. So even on a curved road where a radar or camera might not be able to see this, either maybe it's a vehicle that was broken down in the middle of the road, or maybe it's actually stopped because of congestion ahead of it. But even on curved roads, you can be advised that there's a hazard ahead, and this is a situation that may not be addressable by radar or camera. So this is in a case where this connected vehicle technology can help to avoid crashes. So I showed 3 examples there, and the way we feel this kind of technology will be deployed is kind of gradually growing. So in the first days, when the first systems are implemented and put in the vehicles on the roads and on the infrastructure, maybe there won't be so many vehicles equipped, so you can't necessarily have all the safety enhancements. So you might look at what we call like a driving assistance and information notification, or some roadside vehicle signage in the early stages. And that's illustrated by my emergency vehicle advisory application. As more and more vehicles get equipped, and the maturity of the devices, you can start to do more of the collision risk warning, and even do things with the infrastructure like change the timing based on the number of vehicles approaching the intersection. So the idea is to kind of have a gradual approach and have a phased approach where applications and scenarios that are supported by such systems can evolve. So one way to do that in the automotive industry that we've thought about, one possible configuration option, is to have actually the connected vehicle system installed inside the vehicle with maybe some initial applications. But how do you, as more and more vehicles get equipped, how do you kind of upgrade that application scenario? So one of the ways we thought of could be kind of like a hybrid approach, where the application could actually reside inside a handset or a carried-in device and successfully interface, but with a standardized interface to the safety system that's already in the vehicle that has been kind of sanctioned or certified to perform these minimum performance requirements necessary to do some of these advanced safety applications. And in that way, we can introduce new applications with more maturity later on in this deployment cycle. And we actually did one of these examples, which you can see here, about road advisory, where the application actually existed inside the carried-in or handset device, but the kind of basic framework for exchanging these safety messages was installed in the vehicle. So that's kind of what we've been doing in the past, and I didn't show you like a live example of a V2V application, but we've been involved in this model deployment, like Mike mentioned, and these applications actually do work and can actually prevent crashes. But we think there's more to it than just advising the driver of potential hazardous situations. And so we have a vision of how we can combine active safety or advanced driver assistance systems with connected vehicles in the future. So here I show illustrated what I call external connected automation sensors. So a lot of the advanced safety systems, or what we call active safety systems, depend on vehicle kind of autonomous sensors and functionality. So these are the traditional ones like cameras, radars, lidars, even ultrasonic for low speed, close in. And these are sensors that have been commercialized and deployed in certain systems, as Mike illustrated in the presentation before. But in any case, if anyone who's dealt with these kind of sensors can understand that no one sensor is ever perfect in every condition. And so probably it's likely for connected vehicle automation that there will be like a family of sensors to include the traditional ones like lidar, cameras, and radar. But we also feel this connected vehicle, connected automation concept will use kind of another sensor like a V2X or some kind of connected vehicle sensor, and even detailed map data to end up becoming what we call kind of a connected automation kind of suite of sensing capabilities in order to prevent crashes and automate driving through a connected and autonomous sensor combination. But connected vehicles is not just looking outside from the vehicle to the environment, it's also how the vehicle addresses the human being, the human operator. And in this case, I call these internal connected automation sensors. So in one case, in order to complete this connected automation concept, the driver may or may not be necessary to overcome some certain conditions, some certain unexpected conditions. And so one of the ways that Denso has looked at this kind of holistic approach to connected vehicle automation is to actually sense what the driver is doing. So we have these infrared sensors that can map out a face and find out even if the driver's eyes are closed, like they're getting drowsy, you can time how many closures per second or whatever the metric is. You can see whether you're looking to the left or looking to the right, or looking behind you, or trying to pick up your cell phone that dropped on the floor. And so this is a way that the vehicle connects not just to the outside environment, but to the driver as well. And that goes the other way around, because the driver has to know what's going on with the environment. So another, what we call an internal connected automation sensor, is how the driver responds to the signals and to the information that's presented to them. Where cognitively can you react to indications that may not be for automated response from the vehicle, but the driver has to actually do something because of the hazard in place. And when we kind of combine the automated response and the driver's knowledge of the situation, we can look to the future and see where this kind of connected vehicle automation could actually assist in moving from one place to another in a safe and efficient manner. So this is a kind of an example of what I might think a combination of what I call active sensors and connected vehicle sensor might be able to do. So ordinarily in today's world we have a stop and go traffic signal indicator, and it's usually safe but not always safe, and in some cases where there's no cross traffic, people are sitting at red lights and using up fuel and wasting time. So the idea of having a connected, automated vehicle system can allow situations like unsignalized intersections, but still make them safe. And in this case, I wanted to illustrate that even though the forward-looking radar might not see the intersecting truck, it can still allow for automated speed response in order to prevent collisions even without a signalized intersection. So I think even though this is maybe not doable today, it's kind of a vision of what the future of transportation might look like if we were to realize this connected automation vision. So how do we get there? Really, it's a combination of more than one concept. Number one is you have to have effective sensors. This is a picture of a camera, but radars, lidars, as I talked about, will all be used in connected automation scenario. Secondly, it's important to still keep the driver inside the loop. So to understand what the driver's doing, how they're acting, are they aware of the driving situation? Can they take over an automated system if need be? Is another area of study that's going to be necessary in order to safely deploy some of these systems on the roadway. I talked about the driver monitor to understand whether the driver is capable of taking over in an automated system scenario as necessary. And fourth is this kind of connectivity portion where even these autonomous sensors such as a radar or camera may not even work under certain situations. So we have this kind of vision of a crashless automotive society, not just a safer automotive society, but a crashless automotive society. So, Mike mentioned this, and in terms of connected vehicle automation, one of the kind of obstacles we need to overcome is that every vehicle would need to be equipped with such kind of equipment in order to reach this kind of ultimate vision of crashless society. But we can get started in certain areas. Kind of the idea we have is, I think somebody wrote a report that by 2050, 70% of the world's population will be concentrated in around 250 mega cities. So a lot of planning people, transportation, livable community planning people are talking about a different idea of what a city center might be, and the idea of these kind of what we call personal transportation systems may operate under environments different than today's highway and major arterials. So the idea is maybe we could start from scratch. If you have a city center that's being planned around kind of a more livable, sustainable society with these personal transportation devices, why couldn't we make a requirement to operate in these neighborhoods that you have this connected automation vehicle requirement, so that every vehicle being deployed in this kind of city center neighborhood would need these capabilities. And here's where you could start to realize crashless society in certain regions, highly populated regions. So in summary, I wanted to say about four concepts I want you to take away from this. One is that this V2X, this connected vehicle system, crash avoidance system, is actually effective at performing that function. It has been shown to actually provide crash avoidance. We believe that, secondly, we believe that connected automation provides advantages, so that some of this automated scenario where the car reacts to its sensing and the driver doesn't, in fact, can provide certain advantages. We also believe the road to automation includes connectivity to the driver. So connected vehicles, not just a cellular telematics platform, but also senses the driver and its interaction with the vehicle itself. And we believe in the future to look towards these alternative transport vehicles might be a good place where we can show the effect of connected automation in 100% deployment situation in highly congested and populated regions. So that concludes my presentation. Thank you for